I think I should start with. So that's how my talk is organized. Uh, Considering that for some of you, it's quite a new topic. I'll start with really basic thing like what is blockchain, and why do we need blockchain when we already have things like distributed databases, and some of we already know cryptography, like how digital signature works, how hashing works. And interestingly, this semester I'm teaching data structure and algorithm to my students. So here in BHU. So the interesting part is like this year only I'm able to connect that how the topics that we learn in your academic career uh, and how these things can be utilized when you group different topics like as I said, distributed systems, cryptocurrencies, uh, some bit of mathematical modeling, and then you can get a really cool technology out of that. It's not like we are going to discuss anything really new. The only thing is like blockchain is a buzzword. People try and understand things in one go, and that's where problem lies. So then I'll briefly talk about history of blockchain, that how things evolved, and why I have this point in this outline is like it's really interesting history. You all would like that out, and after that we'll be talking about what are the basic building blocks of blockchain. What are the things that matters when you're going to design blockchain? And while discussing those vital components, I'll be talking about what exactly in terms of practical knowledge, in terms of theoretical knowledge, in terms of kind of idea building, like uh, how all these concepts, tools, technologies can be put into perspective to get things done in a far better way compared to the traditional approach that we are still following in our day-to-day real life. And then I'll be briefly covering like some of the applications that are already there. People are using it out, and to give you just an example, and I'll elaborate on that later during my talk. That even I was going through one news article, and it said like even CBSE, Central Board of Secondary Education, is going to utilize this blockchain technology in coming up with results. So it's no more in books. It's no more like the people are only coming up with research articles. The thing is like people are coming up with more and more applications. It's no more like when I say blockchain, it's just cryptocurrency or it's just Bitcoin or any other because we have more than 300 cryptocurrencies today. So blockchain is more than that. Next, we'll discuss like what are the practical issues, what can be the path ahead, where we stand, what are the areas where we should contribute more, and at the end, obviously, we'll be having some references bibliography here. So that's that. Let me start with a really simple question, a really simple story, and I hope most of you would have probably heard of that story if you have if you have heard of blockchain and what are the problems, what are the core problems that blockchain is promising to solve. Then here's a scenario, and I knowingly have these two names over here, Virat and Anushka. Karina is like everyone today knows about these two individuals in India, actually, and not only in India, and around the world as well. So just a fun part that you also be over here in this class only. We are no, it's 2 o'clock, 2:10. So if some of you are not mentally present there, then it's for that purpose only. So if you see here, this person A wants to transfer 100 rupees of amount to person B, and The existing scenario, if I talk about banks, then what happens? They say, okay, you need to trust on us. We have a really secure systems. Though we know that in past 5 years or 7 years, I think at least two, three instances I can elaborate where banks, they accepted that there was some data leak, there were data breach, and that can be catastrophic in an economy like us where we are. That's lots of things on a stack. If RBI doesn't work in a transparent manner, if SBI or for the matter any other bank doesn't work in a way they should be working. So the question comes here is like how you are going to make sure that these banks are performing in a way these banks are following the rules being met by RBI, and no bank in the system is kind of a malicious bank. When I say malicious bank, or when I say a bank which is how can I say, a bank which is not following the well set rules and standards. Like if you remember last to last year, there's one cooperative bank in Mumbai, Maharashtra, I guess. So there were some issues with that bank. Officials of that bank, they were involved in some sort of corruption. So how to avoid any such scenario? And not only that, if you want to transfer 100 rupees from A to B, what's happening? 5 rupees is being charged by bank itself, saying that hey, it's a processing charge. We have our employees, we have infrastructure, we are kind of paying heavy money for software installations and all. So in that one case, you need to pay 5 rupees to bank, no matter. Okay. So if in order to transfer this 100 rupees to person B, you have to pay 5 rupees to bank. So that's the first thing that you won't like. What you want to transfer this whole 100 rupees to this person B, and you don't want to give any money, any kind of money to bank. So that's all the idealistic view, like how what kind of system do we have so that we need not to pay even 5% of that amount to the third party or to someone to whom we can trust upon. Not only that, if I talk about if you I don't know, like whether you have gone through the rules for NEFTA or not, but if you want to transfer your money from one account to another through NEFT, then they said, hey, we are gonna do that in bulks. So when I say in bulk, that means they club let's say 100 to 100 transactions, and probably after half an hour or some set period of time, they say, okay, now I will perform that transaction. That's how they work in case of NEFT. So the question comes over here, like why is it that I have to wait for 30 minutes? If it's my money, I should be able to transfer it immediately to person B. The third thing is, as I said, if bank is not behaving in a proper way, then you are left with no other option. Your money is kind of at risk. So all these problems were motivation for coming up with blockchain. As I have, this can be visualized in other way as well. Like if you, I have experience of Bangalore. So last time when I went to Bangalore, it was really hard for me to rent apartment. Like I had to pay brokerage charge. So in order to get a house there in Bangalore, you would have to at least pay 15,000 to broker, then 15,000 as the first month's rent, and then around 70,000 as the security money. And why am I discussing all these things is this problem can be solved using this blockchain technology, and that way we can eliminate the broker. Because broker is doing nothing, he has the knowledge of the local system, like who's willing to rent his house and all. and he's charging a really hefty amount of money for that, for for providing that service to you. So in no way it's good, but since we don't have, I haven't had any option, then I had to reach out to broker, and rest, you all know, you all would have faced that problem in your real life. Uh, so, so all the things zeroes down to that. Hey, we have the bank, and let's take SBI in this very case. It's a respectable unit. One can trust upon SBI that they have a good infrastructure in place. Their security mechanism is great. You can without any hesitation use their internet banking and all. But again, it's a central body, and the data is going to be placed on SBI servers only. And to provide you that service, what they're doing, they are charging you high fees. They are saying that you have to have, let's say, if you belong to category ACT, then you have to have probably 5,000 in your account. And if you don't have, they charge you. They say they, I think, deduct around 30-40 rupees from your account on a monthly basis if you are maintaining your minimum account thing. And that's happening. That is started, I think, again, that is started in 2-3 years back. And before and all, we haven't had any charge for. We weren't used to penalize for not having minimum amount in our bank. But yeah, that's happening now. So all in all, what I'm trying to say that it's really costly solution to use banking service these days. For every transaction, for every service, right from ATM to credit card and all, they pay, they charge you. And after that, if something goes wrong, you are asked to wait for sometimes 48 hours, 72 hours, and sometimes even weeks. And on top of that, because I have few of my friends in banks as well, they sometimes say, hey, internet is not working, and this service is down, that service is down, and probably you should come tomorrow. So all these problems we face with banking systems, and but why do we need bank? We are having bank as a middleman, as a trusted party, so that we can we should be able to transfer our money from let's say I want to transfer money to my friend. So that in order to make that transaction happen, we have to have our account in bank. So what blockchain can do is blockchain can make sure that you don't need any banking system. You and your friend can communicate on your own. You don't need any person to act as an intermediary between you and your friend. And how it's gonna happen? It's so blockchain is in simple. It's a time-stamped append only log. So I'll discuss each and every term in detail. But for now, just think of it like timestamps mean like let's say if I want to perform a transaction right now, so it's 218, let's say 42 seconds. So this time will be recorded in a log. So log is nothing but just a history. And when I say append only, then append only means like you can append the new record only at the tail of the existing data chain. So that's that's the meaning of append. Even in file system, you can insert a line in a file or probably append a line. So that's the same thing. Then I won't take much time to explain this whole thing, but yeah, in 2008, this all like started, more and more people started taking interest in, because there was a paper from Satoshi Nakamoto, and he came up with an idea. I don't know whether it's he or she, because no one knows that who is Satoshi Nakamoto. There's so many people claimed after 2009, hey, I only have come up with this idea of electronic cash system, peer-to-peer electronic cash system. But it's a mystery. We don't know that who was that person. But yeah, he do came up with a paper, and title was Bitcoin, a peer-to-peer electronic cash system. And for the first time, he came up with an idea of having a distributed system, a peer-to-peer system where each node probably is connected with each other node in the system. And he said, probably again, that person said that that's possible without having the third party in between person A and person B. And not only that, in 2009, he then uploaded the code, in initial days, the code of, Bitcoin. So he uploaded the code to SourceForge. So for some of you probably who don't know what SourceForge is, so it's like a GitHub. It's an open source uh, uh, software. You can upload your software on SourceForge. The same way you can upload, you can manage your software using version control thing like GitHub, and sometimes even using DevOps as well. But GitHub is free, then and it's really popular, so mostly people use GitHub. So that code was uploaded in 2009 on SourceForge, and then after that, lots of research interest. More and more people started working on, and the first transaction that happened was like there was a person who bought one pizza in 20,000 Bitcoin. So Bitcoin is a currency in case of cryptocurrency. So like we have rupees, dollar, in the same way we have Bitcoins. So it was around 35 crore. So that pizza, if you buy that pizza today using that amount, then it's 35 crore rupees for buying a pizza. So then it was initial phase, and then slowly we started, thinking of that how we can use the same technology, which can be used for other purposes as well, like for Internet of Things, for smart healthcare, or as I said, it can be even used to conduct transparent examinations, the way CBSE is using. So that's that. People started talking about contracts. So as the name suggests, when I say contracts, smart contracts is nothing but a class in terms of programming language, and what you are doing over here, you are defining the rules. So if there are multiple, if there's something that needs to be done through negotiation between multiple parties, then you'll be requiring smart contracts. So again, I'll be discussing it in detail, but for now, just think of a blockchain and smart contract as a means to communicate between multiple different parties without, without any sort of thing like, hey, you need to trust on me because I am saying that that's why it's right. You don't need to think in that direction. The system itself is transparent. Everything would happen with. No one can tamper what's been done in past. So that's that. On top of that, like we already had our concepts on distributed computing back in 1990, and then once we got this idea of blockchain, first thing that we all should be knowing is it's all on top of distributed network. So network can be three types. In the interest of time, I won't discuss at a greater detail at what these things are. But yeah, centralized system is a system where we have just a single system having entire databases stored. So if you have centralized system, obviously it's one point failure thing. So if main server goes down, no one would be able to access any of the services provided by that application. So for instance, let's say we have this LinkedIn, let's assume that LinkedIn server is installed in, it's deployed in Altona, USA. So what happens then if for any reason, probably for bad weather, for any reason, if things goes down in Altona, you won't be able to access LinkedIn all across the world. Then that means like this system should not be used for fault, if you want to come up with fault tolerant application. Then people came up with two other types of networks. One is decentralized and other one is distributed network. So there's a difference between these two. Some people gets confused with. So when I say this decentralized system, so when I say decentralized system, I guess you all are able to see the screen, this notepad thing. So anyone please confirm this out?
Yes, sir.
Okay,
Yes,
thank
yes, sir.
you.
We can
So
see the screen.
this one is decentralized system. So you need not to so every node need not to connect with every other node, but with these four nodes, if you see 1, 2, and 3, with these three nodes, you can kind of take decision for the entire network. So this one is decentralized system. But when you talk about distributed system, it's kind of every node has to connect with every other node in the system. So it's that simple. I'm not that good in drawing, but yeah. So you can have diagrams something like this, and that can be qualified as distributed system, and the first diagram can be qualified as decentralized system. So why do we need these two kind of settings? So if you see, decentralized one is kind of a more economical solution because you need not to have a mesh topology sort of arrangement. But again, it's less fault tolerant compared to distributed system. So when when we go to design the network, how we are going to decide that hey, I would go with decentralized system or distributed system? So the very simple rule is if you have, let's say, 10 nodes, 50 nodes, 20 nodes, then you should go with distributed network because that gives you the highest level of fault tolerance. But if you have, when you have, let's say, millions of nodes, then obviously this sort of network won't work. It won't be efficient to go with distributed network. So that's the first decision one need to take when you would go to when you would when you are thinking of developing a blockchain. Second thing that comes in our mind, so if you see over here in this diagram, we have only three nodes. So every node is connected with every other node in the system. So yeah, so we are for now going with distributed network to build our blockchain. And why we chose distributed network? Because we are having just three nodes over here. If it's Ethereum, if it's Ethereum or Bitcoin, they are the underlying network is decentralized in their case. So I guess it's clear to all of us. Next thing is it's similar to the traditional transactions. What kind of information we are going to store? We are going to store host sender, host receiver, what amount you want to transfer from person A to person B. So in this very case, from Alice to Bob. And one by one, I will show you that what are the what kind of information, what sort of information one should have in a block. So here you see it says that you should have data, you should have digital signature, and again you should have hash ID as well. But why? Why do we need these three pieces of information? So to explain that out, let's start with a simple thing. That Alice wanna pay $100 to Bob. So that's a pretty much simple transaction. So what happens is, uh, since Alice wanna transfer the amount, Alice would create a block. So block is nothing is, but it's a basic unit of blockchain. So as the name suggests, it's blockchain. That means chain of blocks. So there are lots of blocks that are sequentially changed, and you can't tamper the block that's already validated and verified. So that's the definition of blockchain. So yeah, so if you see over here, Alice is broadcasting this message to every other person. In this very case, Bob and Irving, and now everyone is having the same message that hey, Alice wanna transfer this much amount. So what happens next? that's a problem with this approach. Because if you see this diagram, Alice haven't generated any such message, but Bob is claiming that, hey, Alice paid $100 to me. Then how would you kind of say that, hey, Bob is a malicious known, Bob has wrong intentions? Uh, it's like Alice didn't agree to send $100 to Bob, and this message is actually it's a this should not be added to the already existing blockchain, because this message is not a valid one. This block is not a valid block. And how you would how you would kind of get to know that, hey, this is something that's not been created by Alice, and it's unauthorized way of performing debit credit operations. So, in order to avoid any such scenario, people said that, okay, if Alice wanna send $100 to Bob, then she has to sign that block. So that is digital signature. So let me. So I guess you all can see this sign. That's a sign from Alice. Just a picture. In real case, it's number sequence of bits, probably 30, sometimes 256 bits or 130 bits, depending on the algorithm that you are going to use. But yeah, that's how one can sign and authorize that, hey, I only have created this particular block, and I really want to transfer $100 to Bob. And it's not like someone is masquerading to be to act as Alice. So that's that. With that, we can solve this problem. We can kind of find it out that the message that was generated, our block that's been created, is from the right person. No one else can withdraw money from Alice's account except Alice herself. So how this is gonna work, though it's part of cryptography, but in brief I'll discuss this part as well. Uh, uh, if you wanna open your account and if you wanna trade in bitcoins, the first thing that you would do is you would have to have a pair of public-private key, and as the name suggests, private key is a private thing. And when I say private thing, you should in any case make sure that no one else have the access of your private key. It's something similar to like no one should know your password of your Gmail account, because if someone else is using your Gmail account, and if someone else is being able to send message through your Gmail account, then you only would have to take the responsibility of whatsoever is being sent through that Gmail account. So and public key, again, it's your email ID, because as you know, like what's my email ID, you can easily find that out, that what's my email ID, but no one can until unless I myself say my password, no one else would be able to find out that what is my password. So public key is your email ID, and you can never ever, if you know my email ID, doesn't mean that you should in any case you'll be able to know what's my password. So public key is email ID, and from email ID you can't get password. So that's what I wanted to explain. And when you sign a message, it's a simple thing. What you does is you have message and you have your private key, and with that you encrypt or sign the message. So I guess, yeah, you see over here, in order to sign you have message and private key. And when that particular block, that particular signed block would reach at let's say point B, then that can be verified. This thing can be verified that, hey, it's Alice only who has signed the block, and that means it's a legitimate block, and that should be added to the already existing chain. So here we have three pieces of information: message, signature, and public key. And if if verification uh, after verification, if you get to know that hey, it's true, then obviously you would further proceed for adding that block to the chain. So that's that. That way, if you see this first problem where Bob out of nowhere started saying that hey, Alice paid $100 to me, and after having signature thing with that message, which is Alice pays $100 to Bob. When you have these two things, first thing is message itself, and the other thing is digital signature. Then no one would be able to come up with this sort of message that he said this, and that's why I'm doing this. Okay, so not only that. Now, what happens like Bob, even after this particular block is signed by Alice, Bob still wanna manipulate things out. Bob still wanna, get easy money. And for that, he came up with another idea. And the idea is that, okay, I can't force this signature. I can't, kind of create block on behalf of Alice. But yeah, I can use that same block again and again. I would say everyone else in the network that hey, Alice paid $100 to me, and then again after 10 minutes she again paid $100, and again after 10 minutes she paid $100. So that way, that same block which was signed by Alice is being used by Bob multiple times. So here's a problem because the block is now valid. That's no problem. With this signature, Bob would say everyone else that hey, look at this block. This block is being signed by Alice. That means she has authorized that I should get $100 from her account. So how you would deal with this problem? So to deal with this problem, you need to use hash, concept of hashing. So hashing is a data structure. I guess you all know about that, and how this hashing can, using that hashing you can avoid this problem. So if you know, you know, there are too many hashing algorithms available, already available. It's ready-made. Initially, we used to use SHE 130 and then SHE 256. It's currently a secure hashing algorithm. People are not, as of now, people think like this particular hashing algorithm can't be broken. No one can kind of uh, get input from output. So when I say no one can get input from output means no one can get that what's the message from this 256 character hash code, and how to come up with hash function, hash space, hash table, uniformity, and then security. All these things are, all these things are not part of this blockchain, but yeah, everyone should be aware of that. uh, your hashing algorithm should be secure enough, because again, if you can go from point B to point A, that means the chain that you have, it's no more tamper proof. So what I'm trying to say over here, that Alice would sign this message, and after that Alice would generate a hash key. In this very case, for simplicity, I am writing 2 over here, but it would be in actual 256 characters hash code. So when you have this, hash ID, the next block in the system would come after 2. So that way, Bob won't be able to say that, hey, Alice signed this particular block, and I can use that particular block 3 times, because every time this index or this ID or this address would get changed. So all in all, what I'm saying that you would be having 3 pieces of information. First one is message itself. then digital signature, and then this hash ID. And how you would generate this hash ID? It's using SHA 256. We have even SHA 512 as well. So it's up to you whether you want to use 256 or 512. For now, people, I mean, as a researcher or computer scientist or technologist, we are of the belief that no one can break 256. But yeah, something which is true today can be, it's not. I'm not sure that after 5 years, probably people may break this code as well. So if you want to have more secure system, you should go with SSA 512. That's a new standard. Okay. After that, you see Alice have generated this first block. She signed this block. Then hash ID as well is generated. Now Alice wanna pay $50 to Evan. So how does that happen? So you have block. First of all, you have distributed network. Then you have blocks. Each block has data, and then digital signature, and then the last one is hash ID. With digital signature, the person is telling that hey, it's me only. I'm authorizing. I'm only is creating this block. With hash ID, you are avoiding the problem of reusing the same block again and again. And once you have all these things, you want all these blocks to get changed. And in order to come up with the chain, how you would implement that thing now? So again, I would say it's simply it's a doubly linked list. So every block has like it has previous has, current has, and data. Probably block information. When I say block information, it's three things. Again, I would repeat: data, digital signature, and hash ID. So if you see here, now Alice would again broadcast that hey, I want to pay $50 to Irving. So this message is broadcasted to everyone in this particular network. Once it's done, it's a job of other people to verify this out that hey, it's Alice only, C only has signed this thing. And how this is possible? You see, this two and this two is same. And not only that, the people who are taking who are taking the job of adding two blocks are probably appending a block in already existing chain are called miners in blockchain. So their job is to come up with a new hash ID, and in this very case, it's three. So to give you a graphical view, so what happens over here? How you would calculate the next current hash ID? So that is done through proof of work, and though it's kind of uh, for someone who is for the first time hearing this out, it could be a really difficult thing. But I wanna just let you know that it's really simple idea. What it says is that hey, you wanna add a new block after that, and I have a mathematical problem to solve. I want the new hash to start. I want the leading 30 characters of the new hash to be zero, and come up with the new hash value. Whomsoever would come up with the new hash value first, value of this nonce. When I say nonce, this is x. You see over here. I think it's not that visible. Give me a second. So you see, you need to calculate this out, and whomsoever would calculate this first would be given a reward. So in practical world, it's 12.5 Bitcoin. And when I say 12.5 Bitcoin, it's somewhere around 35,000 dollars. So in Indian rupees, it's around 20 lakhs. So that's the reward one can get for mining blocks, and that doesn't mean that it's a really simple job. It takes lots of computing power, and big players are behind the scene mining blocks are taking the job of adding a new block, appending a new block to the existing blockchain. So that as well I would cover, but for now just think of it like one has to calculate this nonce to add the block in already existing longest chain. So once you are done with this, let's say Bob was the one who has been able to calculate that, hey, here we need three. And after that, Bob would broadcast this chain, this updated global chain to all other people in the system. And I would make it clear once again that this chain or this particular data is available with everyone in the system. Like everyone is having the complete knowledge of what of the history of the financial transactions that took place over a time in past. So, and why do we need puzzle? Because if you won't, create complexity, if you won't add up complexity in adding blocks, then very soon we would reach at the because at the time this whole concept was created, it was decided that we'll be having around 20 million bitcoins, and for now, today we have I think mined around 16 million bitcoins. So we are only left with 40 million. Sorry, 4 millions. So you should one should have to work a little bit. It's not little bit. It's around 4 billion comparisons. So after 4 billion comparisons, probably would have to add. You would be able to add the new block in the system. So with that, you can connect things out. From blockchain foundation perspective, like how this blockchain, how one can trust on this particular blockchain. Why is it that people are saying that hey, one can't tamper this blockchain, and how the chain would evolve with time, and what happens if someone modifies some bit of information in blockchain. So if you remember, probably 5-10 minutes ago, I was telling that, let's say you are using SSH 256 and you have has two messages. First one is AB. Let me quickly go back. Let's say you have two messages. First one is AB and the second one is ABC. So you see, these two messages are quite similar, except the C is present in this very case and C is not present in the second one case. But when you compare this hash values, that's a huge difference. It's not like these two hash values are kind of similar to each other. So that means that even if you change a single character out of the entire message that consists of data, digital signature, and hash ID, the whole the resulting hash ID would get changed. So let's say again, Bob has malicious intentions, and what he did is he actually changed this message. Initially, it's like Alice pays giving $50. He changed the message to Alice pays Bob $50. So what would happen in that very case? Since you have changed the content of this block, so the hash that would get generated with this newly created block, with this modified block, not newly created, with this modified block, the hash value would get changed. So if you see the hash value, the previous hash value of block, let's say it's block number 012. So the previous hash value of block 2 won't be same as the next block value of, next hash value of block 1. So that way, this chain is no more a valid chain. If you see, these other two blocks would be discarded then, because this 3 and this 3 is not matching. That's the ID conflict over here. So that means Bob cannot make any change in already existing block. Now, for time being, just assume that Bob was really a tech savvy person. He not only updated this particular hash value, but he updated hash value of all other blocks. And that's possible when you have a small network. It can't happen in case of Ethereum, because there we have more than 20 millions blocks. And if you want to make changes in one block, you would have to do all these computations. And that's not at all possible. And not only that, with that, Bob would be able to say that, hey, there's no conflict now. But others, as I said, it's a distributed network, it's a distributed system. Others are having this version. Others are saying that that's a true copy. And Bob is saying that this one is true copy. Since the majority, when I say majority, Alice and Irving collectively make a majority out of these three individuals. Since the majority says that the status are probably the correct blockchain sequence is this one only, then this the one that we have in the middle would get eliminated. So that's how using the majority consensus we can avoid tampering in already existing blockchain. Okay. After that. Let's assume that Alice and Bob, both of them are really good friends, and they decided that, hey, we don't like Irving, and probably he's really rich, so why don't we kind of help each other in coming up in creating a majority, and then we'll take all the money from Irving. So if that happens, then obviously Irving would lose all the money that he has, and it should not happen, and it actually would not happen. And how even after you have a majority, how this blockchain system can make sure that no one with malicious intent should take control on the network, and to second please. So where I was. So even when you have a majority over here, you don't know. As I said, when I was discussing this private key, public key concept, that you should in no case share your private key or password of your Gmail account to with anyone else. So what's happening in this very case? No matter you have control on the entire network, you don't know the private key of Irving. So you won't be able to sign that block out. So you have the majority, you have updated the hash IDs through SHA-256, but since you don't know the private key of Irving, Irving is still safe, and you won't be, in no case you won't be able to, in no case you will be able to take control of the system and do injustice to any of the participant in this network. So that's that. Now I'll as a part of foundation of blockchain, I'll discuss that how one can tamper and what's the scenario when this system can kind of fail or compromised. When what's the scenario when Irving can still lose the money even when being the legitimate person or legitimate uh, participating node in the system. And that would happen only when you would allow that to happen. As I said, Alice and Bob are in majority, then obviously they can reach at the consensus that the block or the chain that we are proposing is the correct one. But until unless if they don't have this private key of Irving, in no case they won't be able to sign that block, and the Irving would still be safe in this particular setting. So I would again suggest, because I am of the belief that in coming 2 3 years we'll be having lots of applications based on blockchain, and all these things have already started. After this lecture, you can just go and Google. As I said, even CBSE is using this concept. Banks again are in a process to implement this whole thing out. They don't believe the existing framework where one can go with there are problems like double spending, like the same coin, the same digital signature embedded block can be used twice. So you all should be aware of this fact that in no case you should share your private key with anyone else in this universe. So let me take this realistic scenario, and this one is a decentralized system, not distributed system, because Bitcoin distribute is it's based on decentralized system. Now, if one has a malicious intent, then he or she has to, have more than 50% nodes agreeing on that. So if you count this number, how many users do we have? It's one, two, 2 crores, 34 lakhs, 39,414. And that data is, I don't think it's a recent one. It's like it's older data. So for now, we'll be having around 3 crores users. So if 1 crore 50,000, 1 crore 50 lakhs people kind of started behaving, if 1 crore 50 lakhs people would start behaving as a malicious node, then only this node, this network would start behaving abruptly, like one can lose his or her hard-earned money in that very case. But it's rarest of rare scenario. Like people sometimes come up with cooked up stories like probably China can do this, and some person can do that, but they have really big computing powers and all. But believe me, I mean, it's my perception, like coming up with uh, these many malicious nodes is not an easy job. And even if you come up with that thing, that particular chain would get forked. And I believe that it would be a little hard for you, for people who don't know much about blockchain to visualize. But even when that happens, what would happen would be having two chains going in parallel and forked out. So in that very case, what happens is the chain that is longest one would be considered as the true representation of the money transfer system. So in that very case, also we have some sort of mechanism to cope up with that scenario. So with that, here's the magic of blockchain. You don't need bank. You don't need to wait for 30 minutes to get your money transferred to your friend. You don't need to give that $5 to banking system for utilizing the service. So, and all this magic happens over here in this decentralized or distributed system. As I said, I would repeat again, decentralized system would be used when we have uh, a really huge number of nodes. And distributed system would be used when we have lesser number of nodes, like 50 nodes. Because if in case you have 50 nodes, getting a majority is not a big deal. You just need to find 26 people who are with you. Even if you see in these political scenarios, I think one and a half years back in Goa, majority of people from one party switched they switched their party, and they they probably supported other party, and it resulted into people talked a lot about all this that happened. But yeah, that can happen in blockchain scenario as well. But to avoid that out, we use decentralized system for in case we have millions of nodes, thousands of nodes, and we use distributed system when we have let's say 50 nodes. So if I try and explain you this whole scenario, so in case you have 50 nodes, what happens is all the remaining 49 nodes should agree on the on the message that hey, we are going to add this block. If even a single person is not agreeing with the change, that change won't happen. And that way we are still maintaining this thing, like integrity is maintained. No one would be allowed to take control on the network. So with that, I would take a pause, and I'll have some applications and some cool stuff like how can we use this blockchain concept not only for Bitcoin. So it's not like blockchain is Bitcoin and Bitcoin is blockchain. There are variety of applications. It's really versatile. So I'll take a pause for 2 minutes. If anyone has questions, I'll be open to answer, or else I'll cover the remaining parts, which is application. It's kind of theory thing then. Okay, so any question? Okay, I think I should cover remaining part as well then. So, as I said that it's not only used for cryptocurrencies, Bitcoin, Ethereum, and if you know, like in case of Ethereum, in case of Bitcoin, the currency is Bitcoin itself. In case of Ethereum, you have gas. That's how we measure cost. And let me talk about few other things apart from this debit credit operation. Why I took this example, because it's really simple. I guess you all would have understood that how digital signature can with the help of digital signature, we are making sure that if someone has signed the block, then he or she should not at later stage say that hey, I haven't signed it out. It's not the block that I have created. So it's adding confidence that if I want to transfer money, then I can transfer using my private key, because I only know my private key, and others knows others knows what public key. So what they would do, they would have public key, they would have message, and with that they would verify that hey, this particular block is signed by the legitimate person. And then I talked about hash IDs, where I said that okay, if I have had signed some particular currency once, then that should not be, and in any case cannot be used multiple times by a recipient. And how I can ensure? I can ensure that by having hash IDs, and hash IDs are going to get generated using SHA 256 or SHA 512. Once you have these two things, the next thing would be how you would connect blocks. And in order to connect blocks, we would be having proof of work. And proof of work is nothing but, somehow we need to create that what would be the next hash value. So what would be the next hash value? So every block has three things like doubly linked list, data, previous hash, and next hash. And whomsoever would come up with the next hash value, depending on some mathematical puzzle, like first 32 bits should be first 32 characters should be zero, or anything of that sort. And you can even adjust the difficulty level over there. Like the ideal case is like people say that we should it should take 10 minutes to add a new block in the system. So if miners are becoming more and more powerful in terms of computing power, then we would increase the difficulty level and take more time to solve that puzzle to add new block in the system. So that's the technical part of it. And how can we use this for other domains, except cryptocurrencies? So if you see health sector, these days it happens like sometimes you would have to visit probably 2 3 pathologies to get different tests done, like your blood test, your X-ray report, and I really don't want to add this, but even COVID-19 report, because these days if you want to go to, if unfortunately if you want to visit hospitals, then first thing they would ask for is that, hey, do you have COVID negative report? So all these reports and things and all these testings are can happen, and in general it happens at different places, and you would have to go at different places and collect your reports, and then finally you would visit your doctor. So how hard is this? And it would be great if you have everything at one place, and only you should be able to only you should be able to have access to your medical records, because that has the confidential information. You don't want others to to know about, like, what kind of health issues you have. So in that case, one can look upon blockchain as a possible solution. It has really great transparency. It has really great integrity system, value system, and even doctors would find it really easy to no one can tamper your medical records. If probably 2 3 years back you had some issues, then you would have that issue out. It's not like some clerk would go out and make some changes, of course, that document that's there in physical form in that hospital. So all these are advantages of using blockchain. Next example, though there are numerous use cases of blockchain, I'm covering only two in the interest of time, but there are numerous. So with Internet of Things as well, last time when I was reading a survey, it was like they told, like, by the end of 2021, uh, on an average, because mostly it all starts with European countries, and then we starts adopting. There are many factors for this whole thing, but yeah, the report was that by the end of 2021 or 2022, every person would be having at least 25 to 30 devices, and all these devices would collect data. So at least we have 3 4 devices. We all have 3 4 devices that are collecting data, like your mobile phones, your laptop, your university desktop, your Facebook account, your LinkedIn account, your ResearchGate account. So at least 5 6 sources of data collection are already active with all of us. And once you have this huge data, how you are going to apply that data? Who's going to ensure that your integrity of data is maintained? Who's going to ensure that your privacy is not violated? Who's going to ensure that this huge data is structured in the right fashion? When I say this huge data is structured in the right fashion, what I mean is, you can't rely on a central system, because the kind of data we are generating every hour, if you see, like, YouTube generates thousands of hours of video every minute. So for human being, it's not possible to watch all the video. You can keep on watching. You can, take a place that, hey, I will watch all the video on YouTube, and that's not at all possible. So in that very case, how you would add data, how you can make sure that each and everyone is contributing towards data management, and it's possible only through blockchain, as of now, based on my understanding. So all in all, it's a very promising technology. You can have your account in Coinbase. What they'll provide is public-private key pair, and it should be written somewhere. Yeah, they will provide private public key pair. Then you can even buy bitcoins from some of the sites, but there are some fraudulent people as well. Be aware of them. You can even um, uh, transfer money from your ATM to Bitcoin wallet. That too is possible in today's scenario at some of the places. And when I say, some of you would be wondering that, hey, is that possible for everyone to have the entire log? So to make it clear, I wanna brief that CO here, like 256 for 256 bits for should be bits. 256 bits for previous hash block because we are using SHA 256. Block has again 256 bits, and nonce that you have computed that mathematical puzzle would have 128 bits. So if you add these three, it would be approximately 80 bytes. One byte equal to 1024 bits. So it's approximately 80 bytes. So every block is of 80 bytes. And as I said, every 10 minutes we are generating a new block. So we have 365 days. Every day you have 24 hour, and every hour can be divided into six chunks of 10 minutes. And every 10 minutes you are generating 80 bytes of data. And if you multiply this out, all in all, at the end of the year, storing this huge data would take just 4.2 MB. And again, it's an old presentation. Nowadays, if you have a good quality camera and you click a picture, sometimes it says that, hey, that picture is of probably how many MB? I'm not able to recall. I would have to check my phone, but it's obviously more than 10 MB. So in today's world, storing 4.2 MB of data is not a big deal. All of us can do that. So that's the disk space computation thing. How things are happening, you see, it's block header. And just to add on that, I was not being able to cover that. The first block won't have the hash ID of previous block because it's a root block. It's similar to what we had as a head in a W-link list. And this block is called Genesis block. So with this Genesis block, we'll have all these things stored this way. Second thing, in order to better utilize the space, if you would have noticed that sometime, like if I wanna check for my debit credit transactions that I performed in 2012, it won't be possible for me to do that because even bank have deleted that data because that data is now of no use for us. They say that, hey, data for last 3 years only is kind of retained for use. So that same thing can happen with blockchain as well. Let's say what happened 3-4 years back. After some times, we may collectively decide upon that, hey, this whole piece of information is of no use now. Then probably we can eliminate this particular piece of information, these blocks out there. And yeah, it's that simple. Once you are done with that, yeah, now we are at the last slide. In conclusion, in real life, obviously we also trust each other, but if there's a way that can make sure that even if someone is not behaving in trustworthy manner, system should be working in a right. System should be taking a right decision. So, so blockchain is something that we should be using for our financial transaction, for record keeping of medical records, for academic, for generating results in academic institutions. So, though I don't think, I don't know like whether it's the right platform to share this out or not, but sometimes what happens, I'll share a story like last semester I gave, and like after, evaluating marks of each and every students, I got queries from some of the students that, hey, like uh, they thought like I was really strict in checking answer sheets, and ultimately after discussions, I thought like I should increase marks, probably 5 marks, 2 marks, whatever. Like so, I was being able to update the records even after 1 week, but that should not happen. If you think about it from an idealistic perspective, even I should not be allowed to change the marks once I have done, once I have already evaluated things out, and it's out in public place. But since it's a digital system and I had the authority, then I went ahead and updated the marks. So if we'll be having blockchain deployed, uh, no stakeholder, no one would be able to update things this way. Things would be more transparent. No one would be able to temper thing out. And yeah, with that, and then these are the few bibliographic materials probably one may go through. This person, Professor Gary Gensler, that's a really great lecture by him. Uh, if in case you get some time, I think all of his lectures are more than 1 hour long. So I recommend all of you to go through this course. He presented things quite nicely. Some of my lecture presentations are from his lecture only. Uh, yeah. With that, again, thank you. If anyone have any question, I'm open to.
Dear participants, it's open to you now. If you have any question, you can answer. Anyone has a question, please?
If you want, you
So,
can type in. Yeah.
okay, all right. So I have a small question. It's just a layman question, in fact, but still, let me ask you. So when we were discussing about the decentralized decision making, uh, which I understood is that the decision will be taking coordinatedly. Maybe some tokens will be sharing in between, and with that the decision will be taken. So, but still, a coordinator will be there for monitoring this activity, no, sir?
Yeah, you are right. So when you ask this question, the answer would be like we have two types of methods to work on this blockchain. So one is permission blockchain and other one is permissionless blockchain.
Okay,
So
all right.
when I say this permission blockchain means like you have that same methodology, leader based, majority based methodology out there. So what happens sometimes government bodies say that hey I also have a role to play. I wanna govern everything out. Like I would come up with COVID guidelines that hey 50% of seat in that vehicle should be vacant only. So when this happens, blockchain is kind of flexible enough to accommodate all those things as well. So it's on us to come up with the smart contract. When I say smart contract, that legal bindings, like how different actors would behave, right? So if you define some rule, in case of Bitcoin, it's no one is controlling this out. We have miners; they are doing their job, they are getting their rewards. But when I say that we'll be having many applications in real life application in near world, in near future. So then what I'm saying that everyone have a role to play. Doctors have a role to play that how they want to participate in that system. Patient have a role to play. Government have a role to play. And how that would happen through smart contracts with minimal interventions, with already defined rules that no one would violate once it's defined. So as you said, we have central authority, we have things. So it's not always like, and after reading some literature, I'm of the belief that it's not always bad to have central point, as long as that central point is behaving in the right manner. And how we can enforce that? Through this smart contract, right?
Mhm.
So I guess I have answered your question. If it's not clear, I can probably.
Yes, yes, sir. Yeah. So participants, if you have any more queries, you please ask, sir.
Okay. Again, it's like no one has any question. I'll say that if you wanna implement things in blockchain, everyone uh, one should learn Solidity language. You should be compatible with, in my opinion, you should be compatible with one code editor, which is I use VS Code. I prefer VS Code, but it can be anything of your choice. Particularly to students, to research scholars, everyone should be aware of GitHub, how GitHub works, how to clone repositories, how to, like in case of Ethereum, you have Ethereum Go repository. You just need to clone that out, it's open source, you have all the code available. You need not to start from scratch. So yeah, start your thing and come up with your first decentralized application. It won't take more than 1 week to come up with a simple application. So yeah, that's why I guess I have discussed some of the parts in detail, like why do we need all the components? So we have lots of components in blockchain, but all the components are equally important, and they together make a blockchain. So sir, I guess it's
Okay, all right, sir. Okay, so thank you so much, sir, for joining. Uh, like we'll be discussing again. In fact, this training program, it will be continuing for another 2 3 days, and after that, we have two more phases are there in this training session. So that will happen in the month of November, November first week and November third week. I hope that session also you will join as an expert. So I'll invite you especially for that. And
thank you.
thanks again sir, for joining today.
Okay, thank you everyone. That was nice to be here. I'm gonna leave now. Okay.
Okay, all right, sir. Okay, sir. Thank you so
Okay,
much.
thank you.
Thank you, sir.
Okay, dear participants, you can leave now. We will meet exactly at 10 o'clock, 10 a.m. tomorrow. So please join in correct time. Thank you so much.